Hello students, today I'm going to be talking about how to write a linear equation that passes through 2 points. We're calling them x1, y1, and x2, y2. So here we're just going to be given 2 points as we have in our examples, and we need to be able to come up with the whole equation of the line in slope-intercept form, or point-slope form. If you want to stop there, that is fine. That represents the line passing through those 2 points. So I'm going to zoom in here a little bit so we can see what I'm writing. So we're going to use the slope formula followed by the point slope formula here. So the slope formula, you may remember, is the slope is we call m. That's the letter for slope. And then the formula is y1 minus y2 over x1 minus x2. Sometimes you'll see it written backwards where it's y2 minus y1, but it really doesn't matter. So if you're confused, you see it somewhere else, it's the same thing. All right, and then we're going to use the point slope formula for the line, which is, there's a lot of words like slope formula, point slope formula. It's very confusing. But the point slope formula we worked on in class on Thursday and Friday is this: y, let me use a different color here, y minus y1 equals m, which is our slope, times x minus x1. So if we have a slope and any one point, we can write the point slope formula. We need 2 points to find the slope, but once we have the slope, we can use either one of those 2 points, x1, y1, or x2, y2, to get the point slope formula. And it will become the same thing if we then convert it to slope-intercept form. So it'll look different as point slope formula, but it all reduces to the same slope-intercept form. Okay, so let's apply this. I'm going to zoom my paper up here a little bit. So let's look at 2 points here. I'm going to go through, I have 6 problems on this page. I'm going to walk through the first 2, and then I'm going to video stop and have you answer questions as I'm working through 3, 4, 5, and 6. So on this first example, I want to find my slope first. So the first thing I need to do is identify what's my x1, y1. So x1, y1 is going to be this pair. It doesn't matter, again, which one you label as x1, y1, or x2, y2. You just need them to be different and make sure you're dropping them in to the slope formula appropriately. So slope, m, is equal to, and when I substitute actual values in, I want to be sure I put them in parentheses. And you'll see why when I have a negative value on the second parenthesis here. So that's my format. And I just want to drop in y1 into this position on the top left. So my y1 here is 7. And then x1 goes in this position down here. So that's negative 3. x1 goes down here, negative 3. And then I'm going to do the same thing for my other pair. My y2 goes on the top in the numerator. That's, in this case, negative 1 is my y2. And my x2 is the last number that goes in the bottom here. So the reason I want to make sure we use parentheses here is because when we're subtracting a negative number, as we are in the numerator, 7 minus negative 1, that's not the same thing as 7 minus 1. As I talked in class, we make this is the same thing as 7 plus 1. 7 plus 1 over negative 3 minus 1. So when we can take away the parentheses, but we have to be sure to convert. If we see this minus parenthesis negative sign, just change that whole thing into a plus. Okay, so 7 plus 1 over negative 3 minus 1, 7 plus 1 is 8, negative 3 minus 1 is negative 4, and we can plug that into Desmos or a calculator or just reduce it ourselves, and we get the slope is negative 2. So now that we have our slope, we are good to go with our point slope formula. So I'm then going to apply the point slope formula. I'm going to draw a little line here so you can see it's the next part. Point slope formula, again, I'm going to drop in. I'm going to choose this x1, y1, and I'm going to show you if I choose the other ordered pair that I get the same slope-intercept form. So let's start with this one here. So y minus, and again, I'm going to use parentheses whenever I substitute in a value here. So y1 is 7 equals, I don't actually need to use parentheses for slope because it's the first bit in on this side of the equation. So I'm just going to write negative 2 here. Parentheses, x minus, and then my x1 value is negative 3, so I'm going to use parentheses there again, like that. Now I just sort of simplify, I want to get rid of those parentheses. So y minus positive 7, I can just write that as y minus 7. and then negative 2. I need to, I'm going to leave this as is for now, negative 2 times, I just want to get rid of the inside parentheses first. So x, again, minus a negative number, it's going to be x plus 3. And then this is our final point slope form. If I had used the other pair, I'm going to wind up, at the other order pair here, I would wind up with y minus in this case it says y2 here, but this is going to be, if I just had the one pair, it would be called y1. So I'm just going to use the y coordinate there, equals negative 2 times x minus, and then my x coordinate here is 1. I'm going to put that in parentheses again. And so that is the same thing as y. Here I have y plus 1, because this is subtracting a negative 1. Y plus 1 equals negative 2 times x minus 1. I'm running out of room here. But I wanted to show both versions of the point slope form. Okay, so here I've just rewritten both versions of my point slope form. I just want to show you that they, when we're converting these to slope intercept form, we get the same result. So converting to slope intercept form, first we have to distribute, and I forgot to write the negative sign here. My slope is negative 2. I need to distribute the negative 2 times the things inside parentheses first. So the left side is going to remain the same for this first step. We need to distribute negative 2x minus 6. On the right side, we get y plus 1 equals negative 2x plus 2. And now I need to solve for y. I just am going to get rid of whatever's on the same side as the y. So over here, I need to add 7 to get rid of this minus 7. And that gives me y equals negative 2x plus 1. That is in slope-intercept form, which is y equals mx plus b. Right, that's the slope-intercept form there. And on this side, I need to subtract 1 to get into slope-intercept form. You can see that's going to be y equals negative 2x plus 1. So same thing I got here. Those are equivalent. They look different in point slope form. They are different in point slope form. But once you convert them to slope-intercept, they are the same. Okay, so now we're going to go through the same process with this example. My points are negative 6, negative 7, my x1, y1, and 3, negative 4, my x2, y2. So I'm going to find slope as I did over on this side using my slope formula, m equals, and then I'm going to drop in my pieces once I set up my structure. Okay, so y1 is going to be the one piece that goes in the upper left here. That's the negative 7. The x1 goes below it. And then we have negative y2 is negative 4. The y2 goes up here, so that's negative 4 there. And then 3 goes there. So now I'm going to simplify. Again, be careful that as I remove my parentheses, I don't miss a sign here. So I'm going to have negative 7. Again, minus negative 4, that's like plus 4. Over negative 6 minus 3. Now that's just a minus a positive 3, so that's just the same thing as 6 minus 3 written that way. That gives us negative 7 plus 4 is negative 3 over negative 9. We can reduce that fraction and we get 1/3. Our slope here is 1/3. 1 over 3. There we go. So now we're going to drop this into point slope form. So again, y minus my y1. In this case, I'm going to use this one, negative 7. Again, I just showed you it doesn't matter which one you choose here. If I wanted to use these points as my x1, y1 for this part, then I could do that. And then I have the slope, which is 1/3 times x minus, and my x1, oops, my x1 here is negative 6. And close parentheses. So now simplify this. I have y subtracting a negative 7, again that's y plus 7 equals, the slope doesn't change yet. We only have to distribute one if I want to convert to slope-intercept form. Right now I'm just going to leave it in point slope. So 1/3 times x, and minus a negative 6, again that's a plus 6 there. So this is point slope form. If I wanted to convert that into slope-intercept, we know how to do that now. I'm going to ask you to go ahead and follow the same process for these other problems down below, and I'm going to ask you questions as we go that you'll need to complete in the said puzzle. So for number 3, I'd like you to tell me what is the slope of the line passing between those 2 points. Again, that's the slope formula is y1 minus y2 over x1 minus x2. All right, so you see my solution here. I'm substituting my values for x1, y1, x2, y2 into my structure, and I come up with a slope of negative 5 over 2. So given that that is our slope, I'm going to choose this point, 2, negative 1, to write the point slope formula. So again, that is y minus y1 equals m times x minus x1. So go ahead and now write this, the equation of the line that passes through those 2 points in point slope form. You don't need to go to slope intercept, just point slope. All right, so you've shown here, I've substituted my values for x1, for y1, x1, and slope is m, and this is what I get once I simplify that. Y plus 1 equals negative 5 halves times x minus 2. Now please go ahead and find the slope of the line between those 2 points. Okay, so I've shown you my work here, but you should have a slope of negative 1. Now please go ahead and write the form of the line in point, write the equation of the line in point slope form as I've done here for number 3. So I substituted my values. You should have this as your final result. Y minus 6 equals negative 1 times x minus 1. I suppose if you didn't want to include that 1 there and the coefficient just had negative parentheses x minus 1, that would also be correct. Okay, go ahead and do the same for number 5. Right, so you should have gotten this value here, negative 3/4 as your slope. 6 over negative 8, and you can reduce that to negative 3/4. Now go ahead and find the equation of the line in point slope form, please. Okay, so substitute my values in here and then just rewrote it in a simplified way. Y minus 1 equals negative 3/4 x plus 8. Don't forget that that's x subtracting that negative 8 is my x1 value, so you need to change that to a plus 8 when you write it finally done. Okay, last example here. We have negative 3, negative 8, and 2, 7, so go ahead and find the slope between those 2 points. Right, so you see my work here. Again, substitute these values and a lot of negative numbers. I wind up with this, and this changes to, this is negative 8 minus, that's a 7, it's hard to read. Negative 8 minus 7 over negative 3 minus 2, so negative 15 over negative 5, which reduces to positive 3. Because a negative divided by a negative, like we have here, is the same as a negative times a negative. It should be positive. Okay, last one, go ahead and write this equation in point slope form. All right, and for this last one, I get y plus 8. Again, that's coming from y minus negative 8, changing that to a y plus 8 equals 3 times x. Again, plus 3 comes from x minus negative 3. We need to change that into an x plus 3. Thank you, and I'll see you in class.